Hi, I'm Shay Finney, a fifth grade teacher at Phoenix, and today we're conducting an experiment about light. We're going to do an investigation about how light travels, what light can do with different objects, and how light can be scattered, sent through easily, or blocked by different materials. So, hope you enjoy. All right, so we're looking at the first activity that says light travels. It matches this one up here that says part 1. Thumbs if you're there. When you're there, it looks like this guy, and it starts talking about mirrors. Okay, quite a few. All right, it says listen to the story. So I want you to imagine that Miss Finney wakes up in the middle of the night and starts wandering around her house. And she feels like there's something crawling on her. How would I be able to tell what it is? What should I do? Turn the light on. Would I be able to see it if the light was not on? No. We need light in order to see. Nope. We need light in order to see. So yes, if I wanted to figure it out, I would have to turn the light on. So we're going to make some relationship models of how light works and how light moves. Let's ask this question. Do you know what you can see if you have a mirror? You could see yourself, okay? Yeah, you could see yourself, you could see your face, because a mirror is able to provide a what? A reflection. Very good. So we're going to be utilizing the mirrors today as well. So it says we're supposed to go outside and explore mirrors. Oh no. What's going on? Yeah, it's kind of drizzly, it's kind of cloudy, there's not as much light as we would have wanted to. So what we're going to do instead is we're going to use the mirrors in the classroom. Are we going to use the mirrors as throwing stars? No. We're going to use the mirrors, and I want you to see what can you do with mirrors. Can you figure out how they work? What are some interesting things you can do with mirrors? I'm going to give you 4 minutes on the clock. Everybody ready? Great. Come and get your mirror.
I can see mine.
Yes, go get one, honey. Yes. What'd you do? So you're trying to use some vocabulary. Refraction is a word, but that's not what you're doing.
Whoa, I can see what's behind me. Can you just reflect it?
Let me see your mirror.
Under the light, it's bouncing off the light.
Are you shining? Yes. Are you shining? Yes.
Freeze, you're frozen. Zayn and Kieran said, we put our 2 mirrors together. Try that.
Wait, it's a dimension.
Holy smoke! Puddle up.
That looks awesome.
Feel that?
It's an infinite look.
What are you doing?
This looks like some Doctor Strange stuff.
Yo, that is so weird. Yeah. Put 3 together.
Guys, put 3 together.
Yeah. 4. Yeah, 4. Yeah, put 4 together. Look.
What are you doing? Okay, if you can hear my voice, stomp once. I heard another suggestion from Josiah, Jeremiah, and McKinley. They said they're holding the mirror up and they're seeing something on the ceiling. Try it.
It's an opposite of the shadow.
Because it's reflection of light. It's light.
It's the glare. It's the opposite of the shadow.
You got 1.5 more minutes.
I think we turn down the light, it will shine. What about we turn down the light, we can see it?
Turn down what light? Because remember, they said we need light in order to see. So if we took light away, we would see less, right? less light?
Wow. What if you put one on the bottom?
Less light than what? You gotta go to class, honey. You gotta go to your class. What did you do?
See everyone.
Yeah, we can see you.
It looks like what?
Yeah, I can see.
No, it's like it's reflecting the other side of it.
I can also see
I can see Taylor. I can see you.
Okay.
And Dante and
Logan is over there somewhere.
Yeah, if you do it like right here.
No. We're not still having a conversation because we know what the signal means. So, thank you. If we stopped and listened to one person's suggestions, we should stop and listen to someone else's. The last thing I'm hearing suggested is if you're putting the mirror in front of your face, it looks like the other half of your face is there. So this takes another person with you looking. So you try it, let someone see, then they'll try it and let you see. Dante, turn it the other way so Zayn can see. So we were able to do some interesting things. Do you think that some of the things we did in the classroom we would have been able to do outside?
No.
So light works differently inside than outside?
Yes.
Okay, that's an interesting concept. So we said that we were able to put more than one mirror together. We said that we were able to, sorry, it's stuck for some reason. We said that we were able to put more than one mirror together. We said that we were able to hold the mirror up and see some light on the ceiling. And then Zayn said something about how the brightness, what were you saying, Zayn?
Like when we pointed it up there, and then the light hit it, there was less light.
There was less light than you thought there should be? Or it wasn't as bright as the light bulb?
It wasn't as bright as the light bulb.
Okay, so what do you think was happening to the light?
I guess it got like transferred to the mirror.
So some of the energy from the light went into the mirror and stayed there?
I don't know.
Don't know? Okay. So yeah, light works in a bunch of different ways. We are going to talk about what you observed because the light did end up going somewhere. Sometimes the light is going to bounce from one place to the next. Sometimes light is going to go through objects. Sometimes light is going to hit an object and just get stuck or stay there. So light does lots and lots of different things. It says, can you see behind yourself with a mirror? Try.
Okay, I tried that.
Try right now. You do not need another mirror.
I can see myself.
I see the button. I see Gabby's back.
I see
I
Grace.
see Taylor.
I see Grace. Yes. Behind me, yes, I can.
Thumbs? Thumbs up. Thank you. So it works?
Yeah.
How does that work?
The reflection.
I'll take it if you need me to. How does that work? How are you able to see what's behind you? Like Reese, can you see the couch behind you? Can you see
Yes.
Mr. Finney the shark?
Yeah.
How?
Because I'm looking behind. Because I'm using the mirror to look behind me. Like I'm putting it somewhere where I can see it.
Okay, so she said the object must be somewhere where she can see it. So is light shining on the object behind you?
No, I don't.
So if she can see the couch, is light shining on the couch? It's gotta be. We have to have light to see. Remember the story of something crawling all over Miss Finney? I wouldn't be able to see it if there was no light at all. So light must be shining onto the object. So how is she able to see it if she's turned around? How does that work? Turn and talk, 30 seconds. How do you think that works? So how does that work? You're saying the word, but how does that word? From where? So you're seeing a light bulb? Kiran, you're halfway there.
I think it's because like when you look at it, you can see it, but when you kind of tilt it, your eyes don't recognize it.
Okay, all right. So I'm hearing my name just yelled out, and I'm not sure why, but I'm also hearing some great things you're talking about with your classmates. Put your mirrors down at the center of your desk. So Gabby said it has to do with our eyes. True? Yes. So the light has to end up going into your eye. That's how we see, right? But then Kiran said it has to do with something going off the mirror. Is that true?
Yes.
It is true. The mirror is able to do something special with the light. So I will explain what's happening with this image that would have been cool if we were outside. Oh, actually it works inside. This is what's happening. Look up here. Here's light. We need light to see, right? That light must be shining on the object that's behind you, right? If there was no light on it, we wouldn't be able to see it. So the light is shining on that object, and it's bouncing off that object. That light bounces off the object, and then it hits the mirror. And then it bounces off of the mirror. And then after it bounces off the mirror, I heard someone say it, it must go into your eye. So what we're doing is we're bouncing this light over and over again. Does light travel like this? Like zigzaggy?
No.
How is the light moving every single time? It's moving in a straight line or a straight path every time. So we're going to make a similar model of this in our notebook of how light travels, and then we're going to make a diagram of light as well. If we had gone outside, Zayan was talking about that bright spot. Zayan, that was you, right? Mm-hmm. Yes, he was talking about the bright spot that we were able to make. Could we have done that outside? Yeah. How? How would that bright spot have worked?
The sun.
Does anyone have an answer?
The sun.
What about the sun?
It has light, so bounce to the mirror and onto another object.
Very good. She didn't just say the sun. She explained the sun that has light. The sun is a natural source of light that we get. We're very, very lucky that the light gives us sun gives us just enough light to survive and things. So the sun, which leaves light, it sends it to the mirror. It bounces off of that mirror and it can hit the wall. So maybe another day in the future, on a sunny day where it's not cold, maybe we could take our mirrors outside and give it a try. What is that called? This bouncing of the light. What is that called? Reflection. So I know that we saw an example of a reflection before. Does it only work with mirrors? What's the cat doing? It's laying on a glass. Okay, we could say it's a glass. Sure. Maybe it's water. Okay. And what is that surface doing? It's reflecting. Very good. It's reflecting. So it means it must be bouncing that amount of light. All right. So let's add our definition to our notebook. Gabby F., what were you going to add?
The mirror, if I put my pen over it, I can see the reflection of my pen if I move back and forth.
You could see the reflection of your pen.
No, but like it was like the cat when he was laying down, you could see his reflection on the mirror or the mirror or like there's something clear can reflect. So I don't know how to describe.
You're saying something clear can reflect?
Yeah,
Like this is reflecting? Is a mirror clear?
no, but it's like
No, not clear. But it is shiny. Are shiny things able to bounce and reflect the light?
yes.
Okay, so let's add a decent definition, and then I'll let you try some things with your mirrors and your flashlights. It's that one. Ms. Carrington, do you mind? There we go. So our first focus question is, how does light travel? Very good. It travels in straight paths. And those straight paths are called rays. Just like sometimes you'll see little kids draw pictures of the sun, and they'll draw those kind of straight lines sticking out of the sun. That's because it's traveling in a straight path from the surface of the sun. Would love for you to write this down. Okay, then it says, how can we diagram a light wave and the mirror challenge? What can be done with mirrors? This one's going to take just a couple of minutes. what I want you to be able to do is to use the flashlight. Why would we use a flashlight? Source of light, right? How does the light travel with the flashlight? Oh, I picked the bad one. It travels in a straight path, right? If I block the straight path, what's going to happen? I'm going to stop it, or I could create a shadow or some other things. How do you think it feels with my hand right here? Warm. Okay, so I'm hearing people talk about how it feels. So light might be a certain type of energy. So what I want us to do for a couple minutes is what's called the mirror challenges. It says we're supposed to identify how the light is being influenced or affected. You ready to give it a try? Yeah. What you're going to do is try and do one of these challenges successfully. So what's this picture? That's the flashlight. What is this thing? This is the light. So I can see the light is going in a straight direction and then it's moving in that direction. So what's that black line? That must be a mirror. So what I want you to do with the people that are working with you or beside you is I want you to come up with strategies to solve number 1, 2. If we have time, we can try to do number 3. Okay? And you can draw the pictures here. See where it says, what can you do with mirrors? Mirror challenge. You can just put number 1, draw your picture. Number 2, draw your picture. Number 3, draw your picture. Okay? Couple things. If you're not using the flashlight, turn the flashlight off. Okay? We don't want to waste the battery. We promised we would give them back after we borrowed some from the office. So, you're going to try challenge number 1. Why don't we try challenge number 1 together and then try to do challenge 2 and 3 after? Okay? So, challenge number 1 says, place the mirrors to make the light shine on one side of the flashlight. So, how would it shine on one side of the flashlight? We would have to take our mirror and either turn it one way or the other in front of the flashlight, right? So turn your flashlight on, sit it on your desk. The only thing you need to move is the mirror. All right, I've got 4 mirrors at Zayn's group. Can anyone do this with less than 4 mirrors? Gabby, put it down. It's not going to go anywhere. Just put it down.
It's working.
You're supposed to shine it on one side of the flashlight.
Okay.
Has anybody been successful yet? Okay, I see Reese's group looks successful. Hands off. Look up here. Jeremiah, sit down. Taylor, hands off. Okay, so what did Reese do to be successful? She turned the mirror, I think it looked just like this. And what happened was the light hit here and it shined back this way. Did she place the mirrors to make the light shine on one side of the flashlight? Yes. Do we see the mirror? Bouncing the light. It's shining on one side of the flashlight. Give it a try. Took one mirror. There you go. I see it on Ashlyn's hand. I see it on her. Look, right there. It's bouncing back on one side. Yep, put the flashlight down. It'll stay there. Yours is shining over here. Your mirror is not bouncing the light. Oh, it's shining right here on me. Maybe a little bit lower. See how it's shining on her hand. Is that one side of the flashlight? Very good. All right, flashlight's off. Let's draw it in our notebook. See if we have time to do one more challenge. All right, folks. Challenge number 1. Put a 1. Step 2, draw your flashlight. Braden, can I borrow yours? It looks almost there. Okay. Is that a flashlight, a mirror, and some light? Yeah, his line isn't drawn correctly, but everything else looks very good. So off to a great start, Braden. First, draw your flashlight. Flashlight can just look like that's perfect. Sure. Draw your light, draw your mirror, and draw your light bouncing back. You can draw the arrow pointing how it's traveling. That's a great idea. And just make sure it's shining on that one side. Very good. Is it moving differently now that we're using flashlights, or is it still going in the straight line? Still going in a straight line. All right, let's move on to challenge number 2. We're shining the light in 2 directions. So if you're finished, you can shine the light in the 2 different directions using your mirrors. How many mirrors do you think it's going to take for 2 directions? 2. Very good. So go ahead. That's one direction. How about you try with 2 mirrors together? Remember how we put them together earlier? Maybe we could use that to send them in 2 different directions. So turn on your flashlight. Yep, you don't need a water bottle. Just move it out the way. How can you make it shine in 2 different directions? Okay, wait, I see one direction over here. Where's the other direction? Oh, I don't see it anymore. Hold on. Hold on. All right, I see one direction over here. Nope. Nope. Oh, is it right there? No, that's from the front. You might have to use a different angle, but you're on the right track. 2 different directions. What are the directions? Oh, I see one direction here. Where's the other direction? Here? Can't see. Back up just a little bit. No, put the flashlight down. You don't have to hold the flashlight. One direction over here, one direction over there. Nice. All right. Put things down. Nope, come back. Put things down. Come check out Gabby, Brayden, Ashlyn, and Josiah's group. Go back to McKinley. Go back to your seat. All right. I see one direction shining on her water bottle. Put your hand in front, Gabby. One direction right there. I see another direction shining on Josiah's jacket. How many directions did they make? 2. So if it's able to shine in 2 different directions, they were successful. Nice. Give it a try. Give it a try at your seat. Give it a try. Can you also make 2 different directions? So one shining on her, but the other one is also shining on her. So that's not 2 directions, that's just one. You were supposed to get 2 papers. You can grab an extra one off here. Put the flashlight down. You don't have to hold it, just put it down. Put it down. Okay, I see one direction here and one direction here. Nice job, you guys. Very good. I saw most of the flashlights doing something like this. They had the light on, and it was going in this one straight direction. So how did they get it to move in these 2 different directions? I saw a lot of mirrors like this. So that means that the light would hit and go in that kind of direction, or hit and go, no, I think I drew it backwards. Hold on. Okay. There we go. So it would shine this way, and then this light would be sent that way, and this one would hit and go that way. So these are your 2 different directions where the light was shining. Is it still traveling in a straight line? Still traveling in a straight line. So now let's just describe a definition of light. We said that sound is a form of energy. Is light also a form of energy? Yes. So think about when you go outside and you stand in the sun, what do you feel? Or when we turned on the flashlight and we looked and we said what we thought would happen, you said you felt like my hand was getting warmer. Or maybe sometimes you'll light a campfire and that warms you up, right? So light is a form of what? Heat. There's a special science word for heat, and that's radiant. So we can say light is a form of radiant energy. And next to radiant, we're just going to put heat. It's a type of heat energy. And it travels in blank blank. What is that? It travels in straight paths. And it travels as a what wave? What kind of wave is a sound wave? Slinky. Looks like the spiral, right? Compression. Longitudinal. Is this the same? No. Light's actually special. It travels as a wave and it also travels as a particle. So this is that up and down wave, kind of like what's in the ocean. And we call this a transverse wave. Someone said it was on the test. Yes. On your SOL, they're going to compare the two different types of waves. Is it compression, like sound, or is it transverse, like light and oceans? And then the last thing we'll do before we do our other experiment is we'll draw a diagram of a wave. Is it going to look like the slinky or the up and down? Yeah, it's going to look like the up and down. And there's some parts of the wave. Anybody have a guess?
I think the top is the crest.
The top is the crest? How did she know that? The top is called the crest. Anybody else know a part of the wave? What's the trough? That is the bottom of the wave. It's crazy that you guys know this. How do you know these already? What else? There's two more.
In between them is the wavelength.
The wavelength. Ashlyn is also correct. Anyone tell me how they know? How do you know these parts already?
Because we already studied this in our sounds.
So are sound waves parts the same as light wave parts?
Yeah.
So when we talk about ocean waves, are they also going to be the same parts?
No.
Yes. So yes, we already learned about it, and when we continue working on this, we will learn about it again when we talk about the oceans. We're missing one more, which is how tall. Anybody remember what that one is called? Amplitude. Amplitude. Questions for me about this first part? Okay. The second activity we're going to do is talking about what else can happen when light strikes an object. Someone said, well, it kind of stops or gets stuck there. So we're going to talk about what the different objects can do when they hit, when light hits them. Okay. It says, how does light interact with different objects? And we have a container of objects, and one of my lights right here. All right. So I've got some objects in this container. Yep. Thank you so much. And we're going to test them out and see what happens. Oh. The first one we're going to test out is this fabric. What's fabric used for? Clothes and things. I think my cousin had a baby, and I made this into something.
A blanket?
I don't know. Okay. So we're going to say what happens when the light strikes this object. That's our plan at this point. So I'm going to put this guy right here. Yep. If you're clicking, tapping, making any noise, please stop. Oh, sorry. Maybe I'm tilted up here. Okay. Let's turn off. Can you turn off that light, please? What's going on? Like, kind of going through? Okay, so let's put on our list, kind of. I mean, that's technically what happened. Kind of goes through. It should all fit in the box, but I wrote way too big. So kind of goes through, we're going to put this as fabric. It kind of goes through. What's this?
Oh, cardboard.
Cardboard from a box of diapers. What do you think is going to happen? What's happening? It's making the light shine. That's not what's happening. What's happening? It's not shining through. Thank you. So should we put the cardboard here with kinda, or is this something different? Different. Okay, so let's change to not going through, like Taylor said. And we'll write that this is cardboard. Oh, cardboard. Not going through. What else do I got? Oh, I got a styrofoam cup. Styrofoam cup. What do you think? Not. It's pretty thick. Kinda.
Fully go through.
Like a lamp.
It completely goes through?
No,
It's kinda. You want to put it as kinda?
No.
Well, yeah, you can see it, but is it completely or is it kinda? Okay, raise your hand for, I heard someone say it's not going through. It is going through, right? We don't have to consider not going through. Is it going through easily or kinda? Okay, so let's put it under kinda. We don't need a new category. We can put it, okay, styrofoam. Cup. Kinda goes through. Okay. Next I have this bag. There we go. What do you think? Not really a difference at all.
It's just like you can see the bag.
So, do we think it's the same or do we think it's something new? Okay, what do we want to call it? All the way through? Completely through? Easily through? Completely through? Okay. We can use your words. Completely through. And we can say this was a clear bag. A clear plastic bag, maybe? What about this small glass?
It will go through. It's gonna go through. Kind of. It's completely
So it's kinda or completely? Yeah, I think it's completely too. It's completely going through. So we can say glass. Okay. What about aluminum foil? It's shiny. It's, what do you mean no? It's not going through. Like a little bit? It's too thick? It's very thin. Very thin. So if I made it thinner, now it's going through? There's holes in it, yeah. I mean, are we really undecided or do we know? Okay, so we can call this what? Kinda? Okay. So we've got these vocabulary words: opaque, translucent, transparent. And these are describing those materials. If the materials do one thing to the light, it has a certain name. But if it does something different, then it has a different name. Opaque. This is this guy, the cardboard and the foil. So what can we say about opaque? Those are materials. Ooh, I like it. Materials that block light. Last year, they just wrote block light. They didn't even write materials that. They just said it blocks light or stops light. Okay, so those examples would be cardboard, foil, a TV, a piece of wood, a person, a couch. When the light shines on them, what happens? It just stops. It hits those objects and it just stops. It doesn't go anywhere. Is the light gonna whoosh and go around? No. Light travels in straight paths. It's gonna get blocked. So which one is translucent? Translucent is this guy. The kinda goes through. Do we want to say kinda, or do we want to say something else? Some goes through. Sure. Okay. Some light goes through. We're also going to put scatters. It kind of scatters and moves the light around. That's why it's kind of like blurry looking. You'll see that word scatter on the test. So what are things that scatter and blur the light? Your sunglasses. If you're wearing sunglasses, are they the same as regular glasses? No. No, they're kind of taking the light and stopping some of it, so it's going to blur it. What about wax paper? That's going to scatter and blur some of the light. A stained glass window, that's going to do some of the light. Like a plastic milk jug. It's not clear, so it's going to scatter some of the light. Lots of things are in this translucent category. So opaque means the materials block the light. Translucent means that some of the light goes through. So what does the transparent mean? All of it. Okay, so we'll put all light goes through. These items are going to be, for the most part, clear, right? A clear window, a clear glass, a clear plastic cup, a clear plastic bag. All of these are going to just let all of the light go through. So like the windows to our classroom, those are transparent. The window to the door is transparent. Just all the light is shining through. You should have these 3 definitions written down. Any other questions for me? I'm hoping that you're taking away from today that light travels in straight paths and light can act in different ways with different materials.